So, I just put in a syllabus, copied and pasted it here. Okay. The key idea which we will look at is, we have started already introduction, we will talk about important variables, we have talked about it, and then we will talk about some case studies. Okay. That is the first part. Then we will start looking at descriptive statistics. Okay. So, I will do descriptive statistics and then go to case study so that you can relate to. Okay. So, we will do descriptive statistics and then followed by measures of dispersion, measures of spread, all of those, and then some case studies, and then we will talk about probability, because I will introduce inference there and inference will require probability. Okay. Descriptive statistics does not require any probability knowledge, but the moment you talk about inference, then you will require probability. So, we will start introducing probability, we will cover a bit of probability theory and then go on to hypothesis testing. So, we will go up to ANOVA, so hypothesis testing and then regression followed by ANOVA, and towards the end we will also learn about how to deal with things without having a model, that is called non-parametric approaches. So, many times the sample in the clinical study will be less to make much assumptions or to build any models, and that is when you want to look at some non-parametric tests, and that will be covered towards the end of the course. Clear, right? This is what I intend to cover. If time permits, we will cover more. Okay. I will try to balance between the content, the what I call the statistics and probability aspect and the bio aspect. So, the last class we talked about various, I think this is where we stopped in the last class. Okay. So, what does a biostatistician can do? Okay. So, now what does it take to become a biostatistician? What are the techniques, the things you should be knowing? So, you start from, as I said, statistics starts from acquisition level. So, data collection, that is the key, right, and then once, so this is the design study itself. Then you have data presentation. Okay. How do you present the data so that it is meaningful? So, if I want a 1 minute or 2 minute summary of the data, what will you give me? Okay. Then we have this descriptive statistics. Okay. Numbers, the first one is all about graphs, presentation, etc. The second one is about numbers summarizing the data. These two are rudimentary in the sense that these are beginner level. Okay. The key component is this inferential statistics. Okay. So, this is where expertise typically comes in, right. So, you talk about what is your hypothesis, what do you infer from the data, okay. What do you infer from the sample that relates to the population. So, when I say inference, you remember very clearly that we inference only about population, we inference about truth, we estimate, provide an estimate of the truth using the sample. Okay. So, let us be very clear what is inferential. When I talk about inferential, it is always about estimating the truth, okay, because truth can never be known. Then we talk about univariate and multivariate analysis. Okay. So, that is what we do, and today if you look at people call different names to statistics and probability, people do some kind of what I call signal processing, people call about talk about signal processing, people talk about statistical signal processing, which is nothing but the fundamentals comes from statistics and probability. And then when you talk about big data, etc., or when you talk about artificial intelligence, machine learning, these are all the foundations. The foundation starts from statistics and probability, right. If I said, if I ask you a number, y x bar is given that formulae of 1 over n summation xi, you will not be able to answer unless you know the fundamentals, and that is the beginning, and that is where we talk about unbiasedness, we talk about convergence, we talk about robust estimators, we talk about best linear unbiased estimator, which forms the foundation for machine learning. Okay. So, this I would consider it as an M0 course for your any higher order data analytics courses. So, without this it is really unfair for you to attend any other course in data science, because this is the ground. Okay. Of course, we will give an experimental flavor, but remember today in this day and world nobody will give you data and tell work on it. If they do, they will not survive long, because today data is fuel. The way you collect data, and if you are collecting data yourself and analyzing, that is a lot more valuable compared to looking at others data. Imagine you work on a public data set, you see where the journal goes, publication goes, a tier 2 typically today, unless you put your efforts to collect your own data. Okay. So this helps talk about data collection as well. Okay, data collections start. So that is where design of experiments, the study. So this forms the fundamental to start collecting data and then doing a basic analysis. From here on you jump to next level courses in data sciences. Okay, let's move on. So when we talk about statistics, we know what is statistics. When we talk about statistics, we talk about two kinds of statistics. One is descriptive, the other one is inferential. Descriptive is summarizing data, summarizing and presenting data, which is the easiest to do, okay, or which is the beginning level to do, right. So there are many softwares. Some of you, have you heard of softwares that only do present data? Tableau. Yes, Tableau is a classic example of just presenting data, okay. So you know what a Tableau expert will get in the market, that is only so much, because you are only visualizing the data, okay. Whereas the next step as a data scientist, if you are looking at, that is where inferential statistics comes in. So when we talk about inferential statistics, we are talking about population, we are talking about a sample, inferring something about the population using the sample, okay. Example, I told you election polls. So this is a classic example of a population versus a sample. So the descriptive data we will talk about it sooner, okay, and now we will start talking about just the data itself, okay. We will understand the types of data, the classifications, how data can be, what is the kind of data you collect, because remember, to give you an idea, a continuous data versus a discrete data, there is a huge difference. The algorithms as well differ. Why? When you talk something continuous, so I'll give you a slightly tricky one. So suppose I have a problem to optimize, let us say Amazon, right. I mean, we will take some examples which everybody know. Let us say Amazon is there. What is the kind of thing they will optimize? They will optimize for optimal routes, optimal route that will reach the customer quicker, cost effective, right. Simple, let us keep it simple, there are so many other constraints, quicker and cost effective, right. Now there are warehouse locations, remember it has to ship from warehouses, right. So from warehouse locations you are shipping it. Now if you do not consider the warehouse, what is the two variables? Time and cost. These two are continuous variables, these are not discrete, like 1 day is continuous, I can deliver any time, right, it is continuous. Cost is also continuous rupees, it is an easy problem. Now I slightly change the problem, okay, this is one set where continuous variables. The other one, I have to achieve this, okay, but I have one more variable, I can build warehouses to achieve this. Let us say I am ready to build some 3 warehouses, let us say I am ready to build maximum of 3 to 10 warehouses, let us say n warehouses, I am ready to build n warehouses to supply to the bigger population, but with a cheaper cost and time. Now is the first problem difficult or the second problem difficult? So even if I give a simple example, I want to minimize, I will tell you why the second problem is difficult. If I have to minimize x square plus some function, you can find continuous values of x, or I give the same function and I say the x should be discrete. Which one is a difficult problem? Continuous is a difficult, that is the answer I thought I will get. but appears that it is not so. The discrete is the difficult. Why? So one case I let x take from minus infinity to infinity, the other case I say x has to be an integer. Which one is difficult? Huh? Why? In the first case the search space is infinity, I can differentiate and get any numerical value. In the second case I have to jump, the search space itself is now discrete, discontinuous or discrete. So I have to search for 1, 1.1 is not a solution, and then from 1 I have to jump to 2, I have to jump to 3. If I enumerate I will have infinity, whereas in our first case I have to solve only once. Here if I enumerate and solve I am going to do it infinite times. Okay, a very simple change of continuous versus discrete variable, right. In one case I expect the solution to be continuous, it will appear that it is difficult, actually the search space is one single big search space. So I go search and then I find out. Now imagine you have a continuous big area where you have to search versus you have buckets of area, I will get tired, right. The solution may be in between, but you do not want that solution, you want a integer solution, right. So a simple change of continuous to discrete variables can be change the entire way in which you approach the problem. So that is why we start looking at the data itself, understand the nuances in the data, okay, and then the constraints. So when we start with, we have these jargons, the data, typically the jargons are a primary data, a secondary data, a variable, a constant. So what is primary data? The name should suggest something. What is primary data?
Directly from the source.
Directly from the source. No. Is there something better? Primary data. It is the data you collect for your experiment. Very simple. It is collected by you for your experiment. So the data is specific. Okay, the data is specific to your application. Okay. So it is the data collected by oneself or yourself for your experiments, period. There is nothing other than that is primary data, because you know the in and out of the data. Secondary data is already compiled by somebody else for some other purpose. Can you give an example of secondary data?
Public data sets.
All public data sets, like Sensex. Sensex is a big secondary data for many purposes, right, or data collected by ICMR, okay, for used for many use cases, or we also use data sometimes from NIH, and then all this health organizations around the globe, we use those data set. That is all secondary data. So any publications or any work on secondary data is usually considered to be what? Good or bad? Good or best, or it is it's okayish, because you have played with the secondary data which has its own constraints, which has its own limitations. Why? Because that secondary data is not collected for your purpose, it is for something else. It also has some data which you can use it, okay. So that is what secondary data is. But then why secondary data? Primary data collection is expensive, data collection is expensive, okay. So we are collecting, so we wanted to, so you all know boxing, right, we have developed a system for boxing where we want to analyze boxers, how do they perform, whether they are punching well or whether how is their movement, whether utilizing the ring, there are so many parameters in boxing. Now one of the easiest thing is to do what? Take some YouTube videos, start analyzing them, okay. If we would have did that way, then our algorithm whatever we would have developed, and many companies today do it, but what we would have developed is will be so little. Why? In a YouTube video it is 3 minutes, I just need to collect the data, the 3 minutes video is given to me, okay. Already they are boxing and they have given the data to me, I just need to analyze that particular video alone where it is clean, okay, and it is just 3 minutes, right. Now in reality what will happen if I go to a boxing court and do the same? You will put the camera will be on, when they turn it on it is on, not every moment they are going to fight, you will have so many unwanted videos, so you have to remove those. Okay, see how the algorithm itself starts changing, you have to remove those first unwanted videos, unwanted images, and then what do? And when they fight it will not be like a match where 3 people exactly will be standing, because match is very different, and you will get what, hours of data. In YouTube they will give you 3 minutes, because a match is over they will go out, and then that is all, the video recording will stop, because somebody is holding a mobile and taking the video, or somebody is did all of this for you. Whereas when you do it in reality, make it to work, you will know that the video is long, so you have to take 4-hour video and cut it into 3 minutes video. So see, adds on to the baggage gets bigger and bigger, right. So the idea is when you work with secondary data, not when you develop an algorithm for secondary data, it is okay, but it is not the best. It is typically expected to do with primary, but primary data is costly. We have spent more money on this. I could have taken without a 0 rupees I could have taken a YouTube video. I spent multiple lakhs in getting this data, because camera, installations, going, fitting charges, right, somebody has to be there, monitor, collect the data, one person stationed there, all costs, that is the cost of doing primary data, okay. So this is secondary I have given, as well as primary we know what it is. So some of the secondary data, vital statistics, that is from Sensex, hospital data, surveillance data, etc. Limitations, I have told you what are the limitations, when was it collected, how long, all of this you literally do not have a hold of the data, you have to just take it whatever is there. So some of the interesting problems with typically the secondary data is confounding effects. There might be many variables in your experiment and study, and they would have only played with few variables, right. So you know, let us say, can you give an example of a confounding in real life? You understand what is the word confounding? Can you give an example of a simple example of a confounding?
Like the data is taken from only one gender.
No, give me an example, give me a practical example. So let us take this COVID example, okay. Now first initially what did they claim?
Pneumonia type.
First when they claim, when you take 2 shots, what did they claim? They said you will not be able to, you will not get COVID, but that is not true, right, that is not true, that did not happen. I think I might have got at least 5 times by now, right. Once I was very serious, but then I am sure 2, 3, 4, 5th one I did not even test, I know it is there, but then let it be there. So I had multiple recurrences, like a friend, it was visiting me. So now what is the other claim then made?
Take a booster dose.
Take a booster dose, I also did, okay, and I hope many of you would have did, and many people got 2-3 boosters also for the safer side, but did it prevent? Okay. So then what is the claim made?
Additional booster dose.
No, then what did they say? You can actually, the efficacy of this medicine is not in preventing COVID, but the chances of getting hospitalized are lower. Now here is the confounding effect. This is a statement made, okay. Now if you notice clearly, this is a statement made during Delta variant, right. The initial variant I forget the name, because thankfully I got that, I got the initial variant, but that time I tested, but then did not take much because I recovered quickly. Delta variant was the one which made me get hospitalized. Then after that there is this Omicron and other sub variants, right. So now Delta variant, they claimed that your chances of getting hospitalized is lower, right. Now Omicron variant came in. Now they said, look, your chances of getting is hospitalized, do not worry. But Omicron itself had a what is known to have lesser effect on the health, right. It may stay for a longer duration, but it really had lesser health, lesser impact to your lungs. Actually it was only doing your upper trachea, I mean the upper this thing, not the lungs. Now it turned out to be great for the company because efficacy has improved, but if you look at the confounding effect, did people did not get hospitalized, is it because of the vaccine, is it because of the booster shots or vaccine, or is it because of the Omicron variant? Nobody knows. That is the confounding effect, right. It played to the advantage of the vaccine companies so that they could survive, but it is a confounding effect. The real test would have been what? In Delta. If this claim was made in in the first variant, okay, and then the Delta variant would have challenged, and typically when you do a study on the Delta variant and then say, look, here is a X number of persons who took vaccine and they were able to, the mortality rate was lower, and the people who did not take vaccine, the mortality rate was higher. Of course that also has to be done with gender, age, etc., age groups, etc., because you cannot leave gender and you cannot leave age. Age plays a major role. If you say 60 plus, above 60 plus, how many died? What is the mortality rate? And above 60 plus with vaccine, what is the mortality? Then you can claim that vaccine had an impact. But that was not done because the claim during that period was it will prevent you from getting Delta, which clearly is not true, right. At least the efficiency was close to 50%, it is like a tossing of a coin, which is what anyway whether you will get it or not is equivalent to tossing of a coin, right. So the efficiency was pretty bad, and I do not see that kind of study ever happened after that also, the efficiency of vaccine, but the companies made good money, right. So this is confounding. Confounding can be, look at imagine the financial impact on confounding, because Omicron was not there, Omicron was there, and because the efficiency cannot be proved now, that is a confounding, right. How do you test whether this vaccine was successful or not on a general population? In your clinical studies, yes, that is a very different story, that is a very small subset. On a population level, whether you estimated the truth right or wrong at a population level, how do you know that? You have to administer the vaccine and go and do a post analysis, which is what usually done when you talk about polio, when you talk about other vaccines out there, when you talk about rabies, right. These are proven, okay, these are proven because the next time rabies, anybody who has who has gotten a animal bite can develop rabies, and how many of them developed without and how many of them developed with vaccine will tell me clearly the efficacy of the vaccine itself, and that is there, the data is there without confounding, but with COVID it is a confounded one. So now there is no chance that the claim what I made during Delta can ever be validated, because the next step was Omicron, whose variant was so small, I mean its impact was less in the health. So we do not know whether it is because of Omicron or because of vaccine. And one of the saving graces during Delta, the amount of vaccines people took, the percentage of population which took vaccine was lesser compared to during Omicron days, right. So typically the company will say, and it is also possible that one more confounding effect is, it is also possible that we would have developed crowd immunity, right. It is also possible that we would have developed crowd immunity, that we will not know whether it is crowd immunity, whether it is Omicron is not really a concern, or whether it is the effect of vaccine, period, over, right. If it was possible to do, then I would say strongly that whether I can recommend the vaccine or not recommend the vaccine. Now we do not have such a kind of study to actually say anything about it. Everybody took it because the world took it, period, right. So, these are confounding problems, these are confounding issues which are really challenging problems, okay. Like sample selection, there itself bias can happen and confounding can affect. If I take all ages and do, I am actually confounding. Why? Because if you take samples for young people who have taken vaccine and adult people, I mean 60 plus who have not taken vaccine, and then compare their mortality rate, does it make sense? Not really. And with patients with history and without history, right, you have to follow that. Already somebody is diabetic and you have COVID, you know the effect, versus a healthy but normal without a diabetic, right. So, this confounding is predominant, and this confounding will be there when you have secondary data. When you have published using secondary data, your claims cannot be tall because your confounding effects are higher, okay. Secondary data advantages, you do not need to reinvent the wheel, okay. Cost is the biggest advantage. So, if you want to do a proof of concept quick and dirty, that is when you start with secondary data, like your hypothesis, is it even valid, is it even working, that kind of study. The basic study is what you look at a secondary data, but not at the product level. A product level cannot survive at a secondary level or a clinical. That is when you make a drug molecule or when you make a medical device, etc., the easiest thing is to do a secondary data and say these are the components, somebody has did it, these seem to work, this sensors, this seems to be working, you can have an hypothesis and generate it. But the moment you start making it, taking to a next level, you start collecting your primary data, okay. Sometimes it may be very accurate, like regulatory bodies, people will have to disclose correct information, whereas to you they need not disclose the right information. So, secondary data may be very accurate, it has a great exploratory value, that is the key word. For exploration you use secondary data, that is like formulating hypothesis to test, etc., because you have enough data. So, you can test hypothesis using secondary data, but when you start developing your own, primary data becomes important. So, primary data comes from typically from surveys, focus groups, questionnaires, personal interviews, all of this is subjective, it has to be kept in mind, these are all subjective. The last one is subjective. Again there is a, even in primary data there is a value affiliated to subjective data and objective data. Why? Subjective data is subjective, simple, I do not need to reveal the truth to you, there is no reason that mankind somebody will give you the truth just like that, why should they, okay. So, secondary data, primary data itself, the subjective data has lesser value, like you ask questions, whether did you understand, what are you going to say, yes I have understood thoroughly, that is what you are going to reply. Whereas I evaluate on an exam and then start observing, then I will know the reality, that is subjective, right. Or when I start looking at your physiological parameters, let us say your ECG, eye tracking, blah blah blah, then what will happen, then I will get to know indirectly how loaded you are, right, are you cognitively here or sleeping, right. So, if you go and ask a driver, a truck driver, or the typical example is either a truck driver or you go to an air traffic controller or you go to railways, loco pilots. If you ask the driver, he will not even open the mouth, he will say I am perfectly alright, because the number of hours he spends in the cabin is equal to the money, right, they are expected to spend certain amount of time, but the moment you start observing them, you will know how tired they are, right, especially in air traffic control. You have heard about air traffic controllers, ATC, right, ATC is one of the worst, because there is no given set schedule, you may be working, the ATC may be working in the night and next day morning, so they do not have a fixed schedule at all, and the number of hours they look at the screen is equal to, directly equals to the pay they get. So now who would want to leave the screen? They do not want to leave the screen, but misattend or no stress or fatigue, what can it result in? If an ATC is stressed, what will happen? Crashes. And do not underestimate that, because there are many near misses which are never reported to public. Okay, only when an accident happens you get to know. Near misses is an accident would have happened but somebody saved, or somebody was attentive to prevent that, not this guy but somebody else, or somehow it did not happen. That is never reported, that only they know. Okay, because I work with them, so only ATC people will know, you will never get to know. Now imagine, if he ask you, he will say questionnaires perfect, personal interview, yes I am alright. When you start doing your observational study, you will know that this guy is like next to sleepy. Why? Because it is the motive is very different, right? He has to be on the job to get earned. So why will you leave the earning, right? So that is where things are. So objective data is of higher value compared to subjective. Primary data limitations, of course the first thing is time and money, nothing else. Do you have the bandwidth, time and money to collect this data? If it is, then that is the best thing to go. Okay, time, money, and how do you administer this kind of, how do you structure this, your study so that you can do a large scale data acquisition. Okay, so I do not know to tell you the wealth of the primary data. You all know this walking patterns, right? Different people have different gait analysis is, it's a very, I am talking about something very interesting. Okay, so people have different gaits, different walking patterns, right? It is not about analysis. One company was just collecting this gait data using insoles or using their own shoes, they were collecting gait data, how walking data. That company got acquired or sold for 10 million USD, 10 million or more than that, 100 million USD, just the data. Which company, what company acquired? Something like Disney. Why? When you want to do 3D animations, when you want to create 3D characters, you want the walking patterns to match the real life situations, right? Nobody would imagine a shoe data collected from shoe insoles or shoes will be valued at 100 million, right? Just the data set. Why? Because that helps them, that data set is much useful for the animation companies to create different characters with different styles, etc. Reality, more reality, adding more reality to the animations, right. So you can see the primary data value, it is just to walking data, our walking data sold for 100 million, that is the value of primary data. Okay. So today more or less everybody is conscious about data, and if you go to today medical institutes or any of the institutes, primary data is valued heavily, you cannot get it without a MOU and without institute or ethics clearance. That plays a major role, ethics clearance plays a major role especially in getting biomedical data today. And our own IIT has an institute ethics clearance which is as tough as any other institute or even slightly higher. Okay, you may want to battle for a year to get approval. Okay.